we have our private instant transactions, right? Once the transaction has been kind of instant locked, you're not going to get any sort of conflicting transactions. And we can check this because there's, I think, what we call like a nullifier or tag, so that when we see something that's trying to span a conflicting transaction, because all private transactions still has to have something, a unique identifier to show that the double spend has not happened, right?
Yeah, of course.
And in this case, there's some kind of nullifier. Sometimes people call it the serial. I don't know what was the exact terminology, but because we can see, like, right, we are posting this transaction, as long as no one else has that same nullifier, we know that there is no double spend attempt. So we can actually treat the transaction like a normal transaction and say, yep, let's lock it in. The masternodes have agreed. Now we're not going to accept any conflicting transactions with that same nullifier or whatnot.
This podcast is sponsored by Coin ATM Radar. When buying crypto with cash, an ATM is much more reliable and safer than meeting some random person in a random place. And unlike an exchange, which could freeze your account, you truly own all the crypto you buy. With Coin ATM Radar, you could find crypto ATMs and other services where you can buy and sell cryptocurrencies for cash. On their website, you can search by coin, address, if the ATM supports selling as well as buying, and you can also search by geo area, country, state, city. You can also check and compare actual current fees at different ATMs. If you want to find out more, head over to coinatmradar.com, which is coinatmradar.com. Hey everyone, I have the fantastic pleasure of speaking once again with the one and only Reuben Yap, project steward at Firo. How's it going, man?
Great. It's a wonderful morning. I guess it's evening there, and thanks for having me on. I think this is the third time, at least third time maybe.
Yes, it might be more than three. I do know that at least one was under the Zcoin era, and then one at least was under the Firo era. It might be number 4 or something, maybe even 5. Who the hell knows? But it's been a long time. But definitely in the first time after meeting you in person, though, which is that's
true.
That is the difference. And so there's not really any one specific news item or agenda or anything, but we sort of got to talking about some things that had some, interesting privacy questions. And as I was just saying, when we were on the before recording, that in the crypto space, including, and I would say especially in the privacy space, there's just so much knowledge that is not shared. Like, people don't know so much, and I include myself in this, of course, about like how privacy tech works, how it scales, how everything else. And so I had a few kind of big points on that. So first of all, I would say that right now, if you could, like, there's so many models for privacy out there, right? So many of the top level whatevers. And so you can't really go over all of them. But in my mind, like, let's just say there's three ones. There's the, obviously there's the Monero's going to something called full chain membership proofs. And then Zcash has their own shielded setup, their own, fully encrypted, moving on to something new called Tachyon, which I've heard a lot about, but haven't really dug into myself, and probably wouldn't understand it even if I did. And then the Firo's Lelantus Spark is, at least in my mind, operates similar to something like Zcash, but is just a different approach of things. And so I know we kind of went into a lot more of the nuance and things other times, but first of all, let's just start with like the Monero side of things. Full chain membership proofs, right? And so would you mind really quickly going over the way Monero works today and what full chain membership proofs would do differently?
Sure. So, Monero uses something called RingCT, which basically is ring signatures plus confidential transactions. Confidential transactions is the part that basically hides the amount. It doesn't do anything else. It just hides the amount. ring signatures is the thing that they're trying to use to hide the sender, right? And basically, how ring signatures work is that you're proving that you are signing something, but it looks as if that it comes from a potential group of 16 people, let's say right now in Monero, right? So whenever you look at the transaction, it could have come from any of these points of this 16 signers, but you don't really know who. So the current way that Monero works is, basically when you are sending with a ring signature, RingCT transaction, obviously it's mandatory. You are proving that you're one of the 16 and your anonymity set is around 16. So that's how it kind of works today. Obviously, I mean, people, obviously when you have the full chain in this mandatory way, you get a decent amount of privacy, but recently I guess technology and blockchain analysis techniques are starting to catch up. I wouldn't say broken, but it's a known, I would say, not vulnerability, it's a known weakness of the ring signature model, that the anonymity set per transaction isn't that great, and it helps. There are techniques that you can narrow it down, right? So like from 16, if I can start narrowing it down a few times, it compromises the privacy, reduces the privacy quite a bit, right?
Yeah.
So now the idea is to have something called full chain membership proofs.
So before we go into that part, as far as the 16, so you send one transaction out, it's the real one is in the 16, and then there's 15 decoys. So as far as the decoys, are the decoys just every one of your transaction all as a new set of decoys, or is there some sort of a sharing of the decoys amongst other people or other people's transactions? Like, how does that part work?
So basically, anyone's outputs can form a potential input, right? And theoretically, it's supposed to encompass all the previous, outputs, but there is a certain algorithm to kind of select a mixture of newer transactions and the older transactions, because if you just do it like uniformly across the board, there are certain attacks where you can say, oh yeah, because there's so much history, and if I just randomly select, the ones that are recent are more likely to be the real one. So they kind of shift the selection to be among the recent ones, so that to kind of reduce the impacts of that attack. So I don't know if that answers your question, but yes, it's all the possible the outputs that form. Like, you kind of have this big pool, and then you select 16 from that pool, but there's a certain algorithm to pick whether to pick from the recent ones or the old ones, right?
Yeah. So let's just say you have like 5 people transacting, and they each have their 16 whatever. If, let's say, several of those, like say 3 out of the 5, completely ruin their privacy somehow by just saying this is the real one, and therefore all the other ones are real. And does that affect the privacy of the remaining 2 people in that subset?
Yeah, definitely. So one of the things also that tends to happen is, they call it the flooding attack, whereby if many people who are, I think there was it looked like to be an attack where there were a lot of spam transactions that were being done on the Monero network, and I think all the blocks were full, right? So if a huge proportion of the transactions are being made by one entity, right? He can kind of use that to reduce the set of the anonymity set, because his inputs are being selected to be the 16, right? So he knows that I can rule this out because this one belongs to me, right? And because,
of course.
Remember, the attack tends to favor. I mean, the algorithm tends to try to favor a bit more recent ones. But if all the recent ones, or 80% of the recent ones, are mine, then I can start reducing the anonymity of those other transactions. Right?
Yeah. So that makes sense. So now, with my head wrapped around that, right? Then full chain membership proof. Bruce, before we go to that, they're called full chain membership proofs plus plus.
Yes.
Is the plus plus just like, was there a full chain membership proof before the plus plus, and now
Yes.
there's a plus plus? Okay, so then full chain membership proofs first, and then what the plus plus is.
Yeah, so there's actually a bit of history. I'll go very quickly, but basically is that Monero identified this weakness in RingCT for a long time, and they were obviously looking for ways to replace it. And the first there was something called Triptych, which was actually inspired by our work at Lelantus. And then after that, they moved to something called Seraphis, which was based very largely off our work on Lelantus Spark. And basically, it would have increased the anonymity set, or at least the way that they were implementing their ring size from 16 to maybe 256 or maybe even 1,000 plus, right? So that was quite interesting. But so now with full chain membership proofs, when they first discovered this technique called curve trees, which is a recent paper, it allowed you to take. It was a new technique that allowed you to use other primitives that if you did it normally would take a very long time. Like we actually tried to implement a Zcash type system using just bulletproofs, and it would take like several seconds just to verify one transaction, which obviously
that's insane.
Isn't great. That's horrible, right? Just imagine you have like thousands of transactions, you just be waiting there forever, right? But then with this new technique, and this is what FCMPs are doing, is using bulletproofs as that primitive that has no trusted setup. Bulletproofs are reasonably well understood. So, and to use that as the basis of ZK circuit model, right? And originally, FCMP was meant to be part of the Seraphis upgrade. So the Seraphis upgrade was based off Lelantus Spark, but because we designed it to be modular, you could replace part of the proof and put in FCMP. So full chain membership proofs was that. But then, for some reason, Seraphis was taking a very long time. It was quite complex. It would have also required people, the Monero, to change their entire address structure, which means that everyone has to have a new address, and that's a bit of a nightmare on itself when you have a very big ecosystem like Monero. Now, so what happened then was Luke Parker or Kayaba Nerve, he managed to say, well, look, maybe we can modify, still keep the existing address structure of Monero, but still have FCMP in. But there has to be a few tweaks here and there. And it also solves this other issue where currently Monero only has incoming view keys. That means if I give you my view key, you can only see incoming, but you can't see outgoing, which means you can't ascertain balance, which is also a problem, right? Yeah. But Luke, in his brilliance, managed to put in FCMP without having requiring the address change, and also get both incoming and outgoing view key support, and that's why that's the plus plus. It comes with a slight performance penalty versus using it in a Seraphis or Lelantus Spark model, but the pros outweigh the benefits, right? I mean, the pros outweigh the cons here, where you don't have to have this huge ecosystem change, and you're basically almost getting feature parity with what you've gotten with Seraphis or Spark.
Yeah. So, what is the performance trade-off for that? You mentioned there's a very small one, but like how much of a trade-off are we talking about?
I think this is obviously they're just estimates, but looking like 10-15% or something like that. I mean, it's not negligible, but at the same time, it's not like an order of magnitude or something like that.
Yeah, it's not going to really significantly affect things. And yeah, just so for the audience to understand about like the view key type thing. This is a whole subject that at some point in the future I would love to dive into deeply as well, but maybe not this time. But obviously with using crypto, you usually I would think you should want to keep everything private. Sometimes you don't want to keep things private. Sometimes you want to reveal information. And if you have a transparent address system, for example, which has its own trade-offs, right? But that's pretty straightforward. Whereas with Monero view keys, they just never were quite at the point where they worked really well. Like the privacy part worked pretty well, but the transparency part didn't work super well. And so being able to have something that works a lot better, I think would open up some new use cases and things like that. And I can't remember what the other part was about all that. But yeah, so basically, the address change. That is, as someone who's dealt with Zcash and all the different address formats, and then has dealt with Bitcoin Cash, going from the legacy Bitcoin format to then the Cash. At least they just did one change, but then Bitcoin Cash forked to Bitcoin as the Bitcoin SV forked off of that, and then they went back to the original one. And I know people have lost funds, and it's just a nightmare. And just getting users to take action to migrate addresses is such a pain. And so just the fact that you have this like switch that now everyone's privacy is way better and you don't have to do anything, I think is cool. Like I have to say, with like every project, like every good project, I should say, optimizes for something that like they do really well, as far as like they want this to be really easy. And one thing that you have to give Monero credit for is they've made using the privacy part of the protocol very straightforward. You could say, you could argue like, oh, you got to wait before sending a follow-up transaction because whatever. You could argue some other things that might not be seamless, but the privacy part, you never have to think about like, wait, did I turn it on the right way? Did I use it? It just, there you go. And so it seems like this is a really cool thing. And I've had Luke on this channel before. He's a very, very smart guy, and I really like his work.
Yeah. So we haven't talked about FCMPs, but yeah, I'll let you lead the conversation.
Yeah. So you kind of mentioned, the things they do to manage to do full chain membership proofs. But then what are full chain membership proofs then?
So full chain membership proof, basically, instead of saying, let's form a transaction with this 16, 15 decoys, right? Now let's have the entire, history of the chain be that decoy, right? So now you don't have to worry about selecting new or old because it comprises the entire history of the chain. So I guess it's similar to Zcash level type of privacy, right? Which was, again, one of the, all the Zcash maxis like, Monero's privacy is crap. FCMPs basically bring it almost to parity with Zcash. And I think it is a lot simpler. It's not using Halo 2 and it's also trustless. So I guess that's kind of like it in a nutshell. It's something that all privacy protocols should aspire to do, to get a membership proof that is efficient and small enough that can comprise the entire history of the chain. That's all what we wanted. Honestly, like ring signatures was, it was great for its time, but it was,
we're talking like
really
2014 too.
Yeah. It's a kind of a stopgap right now. With what we can do with ZK now is just a lot much better.
Yeah, for sure. So you mentioned it's like almost as private as Zcash. Obviously, we haven't got to the Zcash thing yet, but as far as like almost, where is the not as private part?
I don't know the exact numbers, but I believe the figure that was being pushed for FCMPs is like that set is up to roughly about 100 million, right? Well, if I'm not mistaken, Zcash, it was like to the power of something, might be to the billions. I'm not sure, right? But 1 in 100 million, 1 in a billion. I mean, theoretically it's there, but practically no, right? I mean, that's just how I feel about that.
Yeah, so it seems like now it becomes a lot more difficult to, you don't just have a pool of like current users, you can de-anonymize some of them and then the rest have problems. It seems like even if you had a flooding attack of like 80-90% plus of every transaction, it still wouldn't really matter, even if you know all that.
I don't think, unless you can like make several million transactions and you're just going to flood the network anyway and paying for it, right? So I don't think all those like traditional attacks of Monero wouldn't work wouldn't work anymore, basically.
Yeah. So one thing with all this privacy stuff, which not they can try to look to round out the picture because later we're going to go into like the transaction like speed and stuff, but like the scaling thing. So I didn't obviously these aren't like super verified numbers. I just asked Grok. Grok is a pretty smart AI, but it obviously still can make mistakes. But like a Bitcoin transaction is like half a kilobyte per kind of, and Monero currently is like 1.5 to 2.5 kind of transaction kilobytes. And it seems like people say that full chain membership proofs might put it up to like around 4 kilobytes. So maybe 9 times the size of a Bitcoin transaction. It's like considering there's a few different ways of thinking about that. On the one hand, it is significantly more data than like just processing a regular Bitcoin style transaction. On the other hand, if you know too much about UTXO scaling and stuff, it's not like it's going to be like, I don't know. It doesn't sound like it would be like a problem because you can scale to pretty high levels relatively easily. So from your point of view, do you think it's much of a concern to have that transaction size? Like, man, this is going to be big. The blockchain is going to be heavy someday, or we won't be able to scale to the world, or you just think it's no problem at all, or what?
I think it's obviously storage matters, but in the scale of things, there's various bottlenecks that you need to solve the scalability, right? Like TPS and all this other stuff, right? And I feel that sure, storage is a bottleneck, but it's not going to be the first bottleneck, right? You'll be like the validators verifying the transactions and all this other stuff that comes first before you start hitting that. And I feel that at the rate of, take a look at how SSDs and the cost of storage is still continuing to come down, I feel that although it's a concern, it's not, maybe it's like concern number 3 or 4, right? And maybe something like verification times and that would be like more of like a number 1 issue that you need to solve, right? And at the way that Monero is currently like the current volume levels and whatnot, I don't think it's going to be an issue. Obviously, if it scales 100 times, yeah, maybe that's going to be a problem, but yeah, that would be a huge radical shift and I guess a good problem to have.
Yeah,
but remember that Monero does have dynamic blocks, so at least for the storage side, I'm assuming if Monero gets used like that, the price is going to go up. It's also going to make sense to host the node and all these other things. It's just like a flywheel, right? So
yeah.
I'm not too concerned with that. Not to say that it's not a concern, but it's not my number 1 concern.
Yeah. So, I'm sure we'll go into like the mining stuff in a second too, but like before we get to that, so then we go to sort of the Lelantus Spark kind of thing. So more or less, we got into bigger detail on this in a previous show, but just like what's the quick rundown of how Lelantus Spark works, and then kind of compare it with full chain membership proofs, what that will be like, and just see how different they are or similar.
Oh, well, remember that. So I guess like Lelantus Spark is not just like the membership proof. The membership proof is basically a proof to prove that I'm one of these people, right? And Lelantus Spark consists of the addressing structure and all these, basically the framework, right? And Lelantus Spark does all of this with very kind of simple primitives, in the sense that everything is, rather than having one thing that proves a bunch of things, we have specific proofs. Let's prove balance, let's prove membership, and all of these are kind of like done in a kind of a modular way, right? So Lelantus Spark, unlike ring signatures, like we basically have anonymity sets up to like 32,000 or something like that, which is several magnitudes larger than what Monero has currently. And we use something called one out of many proofs, which is a very well understood and not using any sort of fancy ZK circuits to provide this type of stuff. So anyone can kind of understand one out of many proofs, or rather any developer or some guy with some math background, right? Unlike like ZK circuits, which is a lot more specialized. So I guess you can think of Spark as very good modular, upgradable type of protocol that uses something called one of many proofs. But because of its modular structure, we can actually take out the one out of many proofs and slot in FCMPs, so that we also get the same type of privacy as what Monero would get, with even a slight performance like benefit, right? Because our structure is better. So yeah, that's kind of it in a nutshell. Obviously, we don't have to inherit any sort of like old Monero type of address systems. But it's a different structure. It's designed to be modular. That means if there are new proof systems, maybe FCMP is not all that it's meant to be. You can put in a new thing. Obviously, it's not as simple as I'm making it out to be, but it's a lot simpler than having to redesign and rebuild the entire protocol from scratch, which is what we have had to do in all the previous iterations of Zcoin and Firo's privacy protocol.
Yeah, it does seem like the modular approach is, I mean, just from my understanding, that seems like the simplest way. It's so kind of like if I was going to be an idiot maybe, but like look over kind of everything it works, you would kind of compare the way Lelantus Spark's setup is today to full chain membership proof era Monero, except the anonymity set is probably smaller because of the one of many instead of the full chain membership proof. Is that kind of correct?
Yeah, I think that basically signs it out. And also we can extend the protocol easily to also support token types. That means we can hide the asset type as well. So that's quite cool as well.
Yeah, very interesting. And so looking at this, the table that, the all-seeing eye of Elon, I Grok tells me, it says that like Lelantus Spark transactions on Firo are roughly 2.5 to 3 kilobytes right now, which is comparable to current Monero transactions, maybe slightly larger, but smaller than a full chain membership proof size. Is that kind of correct?
Yeah, I would say it's slightly smaller than a full chain membership proof. Again, I don't think it's of a magnitude, but yeah, it's to me it's about there. Yeah.
Yeah. So, is there any I guess preliminary plans or ideas that once full chain membership proofs are kind of completed to sort of use that instead of the one of many proof in Firo?
Yeah, definitely. I mean, we've been in touch with Luke. I mean, he's in principle agreed to assist us with that. And actually, there's a bunch of stuff that would actually make it, in a way, easier. We don't have to do certain tricks that they have to do to make it work for Monero, because again, you have to realize FCMP was originally designed for a Seraphis Spark type of model. So I think obviously we would be benefiting from a lot of the work that Monero has done for the FCMP side, but we intend to basically use the library and modify it so that Lelantus Spark can use the full chain membership proofs. And I think we're not in a rush to be like, oh yeah, I want to beat like Monero to get it. There's actually to kind of like put it like one of many proofs is quite simple. FCMPs, the circuits involved. There's quite a lot of it's quite a complex component just as a membership proof. So yeah, we are looking into it once we roll out Spark assets and all of that. We understand it's also would be a drop-in upgrade, but we're not rushing towards it. But hopefully, we can start work on it next year.
Yeah, that'd be interesting. Now let's pivot to Zcash, right? And obviously, Zcash is a whole different beast. I did a bunch of podcasts about Zcash specifically, but just sort of the high level thing of like how now we've sort of established that, we kind of go on this journey of like Monero has, confidential transactions to hide the amounts. And then there's a ring of 16 potential outputs that then the more recent transactions tend to be favored in. That's getting upgraded to full chain membership proofs, which could be any transaction that has ever existed. And Lelantus Spark's current setup is similar, but the one of many proofs is like 64,000 and not like, what was it, 100 million or whatever the other one was. It's so how, if that's our kind of overview of the way things are, how does Zcash, let's just talk, let's not go through really the history of like all the different like sapling and sprout and all this stuff, but just Orchard, what they have today. What's that like?
Well, basically, Orchard uses something called Halo 2, which is, I would say, a relatively new ZKP. It's not as efficient as something as Sapling. So it does have some performance drawbacks in the sense that it's slower to verify, there's certain things. But it's still, I would say, competitive. I think the proof sizes may be slightly larger than even the thing. But the main thing that Halo 2 removes is the trusted setup, right? And the trusted setup is basically this thing where I always say it's kind of like the one ring, right? When you first set the whole system up, you have to create certain parameters and place it in, but you have to destroy. Everyone has to destroy their part of it, and or not everyone. At least one person has to destroy it, right? And if there's any kind of flaw in the ceremony and all of that, which actually happened with the Sprout ceremony, basically you have an infinite money glitch where you can just print money without people knowing, right? Obviously, I mean, like, a lot of nowadays, trusted setups are a lot more secure and whatnot, but it's still a undesirable property, especially for a protocol that's supposed to be not trusted. You kind of, like the names, trusted setup, you need to trust.
It makes crypto people shiver. They don't like it.
Yeah. I would say in practical terms nowadays with ceremonies with everyone, it definitely is a lot better. But again, it's still a level of trust, even though it's a bit minuscule now, right? So Halo 2 kind of removes that, and they basically have what is equivalent to FCMPs, basically encompasses the entire history of the chain. But because Zcash is not mandatorily private, obviously that set is smaller. But in terms of the techniques, the cryptography, and theoretically, Halo 2 is pretty up there. It is complex. It is, certain parts of it isn't as well documented as the previous things, which means like maybe there's some centralization risk. Like everyone kind of understands like Halo 2, like if you're a cryptographer, but it's the secret sauce that may be missing, that may be it's kind of in the realm of like ECC engineers and stuff like that. That's the secret thing, right? So yeah.
It is kind of so first, just on the trusted setup thing. So that was something in Zcash's past is not applicable to Orchard.
Yes, that's right.
But that's only for the kind of cryptography Zcash used. It's not something that has ever been a problem for Monero, for example. And it is.
Yes.
And didn't Zcoin, one of the implementations, have a trusted setup, but then it hasn't been in something for very, very recently at all?
Yeah, it was a very different type of trusted setup where there was this RSA factoring challenge back in, was it 1991, where it was supposed to test the strength of RSA cryptography when it was new. And there was like a bounty for it for many, many years. No one broke it. And remember, that ceremony was for an academic thing. They did do certain things to destroy those parameters, but they never would have thought like, oh yeah, I'm going to use these parameters to put it in a cryptocurrency, right? If they had compromised that, then the purpose of their study would have been kind of moot, right? So there's a lot less incentive to backdoor that ceremony versus when in Zcash, I'm like, yes, I'm building something that's going to potentially give me a backdoor of cryptocurrency, when then that was a factoring challenge done by a total third party. You just took those parameters and put it in zero coin. But obviously it's not relevant now.
Yeah.
Don't use that.
Yeah. So fundamentally, like I hear that, and a lot of this, of course, the discussion points come from, wars on X, right? People just commenting saying your privacy is shit, no, yours is shit, blah 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 blah. And of course, me as someone like watching the tomatoes fly over and stuff like that, obviously I don't necessarily care, but I'm looking for the grain of truth, and like it's just kind of like when like a couple's fighting and blah blah blah. And that's why your mother told you were adopted. You're like, oh, you were adopted? Oh, I learned something. So in my kind of perspective there, I have heard it said that full chain membership proofs is still a decoy model, whereas like Orchard, Zcash Orchard is not a decoy model. What's the truth behind the, I guess, FUD, let's just say? What are they talking about when they say that?
So actually, this whole talk about decoy models, I know where it came from. It actually came from a talk by Ian Mayers called Satoshi Has No Clothes.
Mm-hmm.
And there he compared Monero's basically current RingCT model to a Zcash. And he was saying, well, when your anonymity set is 16 per transaction, and even if it goes up to something like 1,000 or something like that, it's still not, because he highlighted all this thing like flashlight attacks, flooding type of attacks that can be done because of this. And that's where he coined the term decoy models, and all the Zcash people are like, yeah, everything else is a decoy model. No, but I feel that once you, even Ian would say, once you hit past a certain threshold, of course, you want to say where that threshold, but I'm pretty sure 100 million is past that threshold.
Mm-hmm.
All these attacks that he highlights not be applicable, and that's what matters, right?
Yeah, of course.
So I would say, I don't know. I mean, you want to say decoy model or not? I don't think the purpose of calling it a decoy model is that these class of attacks can apply to decoy models. But if your set is so big that maybe theoretically it's a thing, but you can't use those attacks, that distinction doesn't really make sense anymore.
So it's not a practical distinction at all, since you just kind of have the same thing. But what is the academic distinction? As in, it's like you could be one of the history of transactions inputs there, but does Zcash still work that same way, or does it work slightly different?
No, the thing is that, I mean, Zcash has a limit. It's just a really, really high limit. Like it's 2 to the power of something. It is still a limit, but yeah. So does that mean there's a decoy model? If they don't hit the limit, then it's not a decoy model. But if they hit the limit, then it's a decoy. I really don't think that's even an academic distinction.
Yeah, so it's more of like it's just like, how big is it until it becomes a decoy model to not? It's like, what's the threshold at which the number of power of whatever that you call it not a decoy model, I guess it's kind of like an interesting topic. But it's funny to see that being talked about with such importance sometimes, just like, but so one thing on Orchard, so I looked up on the table again, the great powerful Grok apparently says that the Orchard transactions, and again, as I mentioned, this is just what it's telling me, they could be around 9.1 kilobytes, so pretty,
that's about right. Yeah.
Pretty big. So as far as like something similar to, let's just say, full chain membership proofs, to be like around 4, so almost even double that size. So pretty data intensive.
I would say you use these kilobyte sizes, with a grain of salt. Obviously, it depends on the number of inputs and outputs and a bunch of other stuff. I would just say like it's roughly equivalent, right? Like maybe slightly smaller, might be. Like to me, it only kind of makes a difference if it's like, oh yeah, it's a magnitude larger or magnitude smaller.
Yeah.
Right? Like original zero coin proofs were 25 kilobytes.
Wow.
So that's big, right? But like if you say like 3, 4, 7 kilobytes, and I think even like ZK stocks, everyone's like, oh, why don't you use ZK stocks? Yeah, it's like 100 over kilobytes or something.
Damn. So, yeah, and again, this is something that I have not really heard discussed in the public thing, as far as like, oh, ZK stocks the way to go, everything's the future, use this tech, without seeing like the inherent trade-offs. And like, there was a time when, before Monero implemented bulletproofs, when the transaction sizes were very large. I don't remember exactly how high, but I remember that transaction fees were in the several dollar range, like Bitcoin levels, for a consistent period of time until that was implemented. And so at that time, I thought, oh yeah, this tech sucks. It's never going to work. And then they added bulletproofs, and all of a sudden it was like night and day difference, like so much better.
Right.
So Zcash Tachyon. This is listen, hype is hype, right? But obviously, one thing that it seems to be consistent in Zcash is it seems like they're extremely like research and tech focused as far as like moving the academic state of the art of these kinds of cryptographic primitives and stuff like that. And so, but also by the time that complex moon math hits Twitter, right? Who knows what it's like? People timing this is going to change everything, and sometimes it's hard to kind of distinguish. So first of all, just as the disclaimer, how much do you actually know about this whole Tachyon upgrade, which is, from what I understand, has been pitched as, the next evolution of Zcash that would keep the same great privacy, but be potentially significantly more scalable. So first of all, before talking about how much do you know about it, so people don't go, this guy's a bad guy for lying or whatever, in case something is small and wrong.
I would say I know a good amount, but again, I'm not a cryptographer or technical guy. It's based off of what I've read on the internet. And of course, I cross-check and stuff like that. So, I mean, yeah, take what I say with a grain of salt, but I would say I know more than the average Twitter or X troll. And, I do try to be accurate. But again, take it for what it is. But yeah, I think I would qualify that. I understand the broad strokes of it and its limitations and some of the challenges. But I wouldn't say like, oh yeah, I'm a cryptographer that knows it inside out. No. Yeah, that would be my qualification.
Yeah. So how does it work from your understanding, or will it work? I suppose, because it's kind of a future thing,
I mean, Tachyon, I think, isn't like a privacy upgrade. It's not like an orchard. It's not like a sapling, right? It's basically a way to scale Zcash transactions, make light wallet kind of infrastructure a lot easier, and it also introduces a new model whereby light wallets can sync a lot faster. Because just to kind of give context, like with Monero or even with Firo or even with Zcash kind of right now, right? What you do is that you basically have to look at an entire blockchain and scan the blockchain for your transactions, right? Obviously, in Bitcoin, that's really fast because there's no decryption happening. But with privacy chains, you kind of have to use kind of like a thing to kind of quickly scan through, like which one is mine, right? To identify those transactions that are coming to you. And the fact that you have to kind of look at every single transaction, obviously, reduces sync time. It's a bit thing. And obviously, it kind of works now, but as Zcash is saying, oh, what are we talking about? The billion users. This model is going to be kind of crappy, right? And the current way that Zcash kind of light wallets work is that you kind of request from the server a kind of small summary of basically all the transactions, and what you would have to do is that you would then your local wallet would kind of scan through and say, oh yeah, which transaction are which one are mine, but that summary doesn't contain the full details that you need to use your wallet. So what happens then is that your wallet has to say, hey server, I've looked through this summary, give me these books. I'm looking through the kind of the appendix, right? And then I go to the server and say, I want this book, I want this book, I want this book. And then the server then gives you these books that allow you to decrypt and find your balance and your transactions. Obviously, the server doesn't know the contents of those things that they're giving to you, but it knows that you have requested for these particular transactions, right? So that's so if you are not using any sort of network layer privacy, the light wallet server can say, hey, this IP address requested for these transactions. I know nothing about these transactions, but I know that there's some connection of this transaction with this particular IP address. And that's kind of a problem. And it's also, it's also a scalability thing, right? It's both a privacy and scalability thing. Now, the new way, which again, this is quite complex, it's kind of like oblivious message retrieval and all this type of things, is that now what happens is that your each user kind of uploads a certain key, and the key is not small. It's like 128 megabytes. You need to upload that to the server. The server does what we call homomorphic encryption. Some sort of some sort of homomorphic kind of a thing, where that means they are doing certain calculations to kind of use your key to work on their data. The server doesn't actually know like which transactions you receive, but it's performing the computation, and then gives you that encrypted kind of pre-computed encrypted data to your wallet, and your wallet can easily open it and find what is its transactions, what is the balance, and all these things. So that's kind of it in a nutshell, whereby you are kind of offloading certain things into the server side, reduce the load on the client side, and you can do this in a trustless manner without the server learning any sort of additional information about it. So that's pretty interesting. And it also has the Tachyon algorithm is like several components. There's also like now validators now can do something like aggressive pruning, because now they just retain like part of the state. You don't have to have the history. So it reduces the storage requirements and all of this. But again, now it starts creating almost 3 tiers of nodes. Meaning you have the nodes like the simple node, then you have the nodes that do the oblivious. Maybe the normal nodes may have to do the oblivious message retriever as well, and then you have the archiver nodes, which actually retain the entire blockchain, basically all the data, and not stripping it down, right? So I think it's pretty interesting. I think it's pretty cool. Obviously, if you are running a public server that is serving many users, remember every user that wants to use like a particular public server, that server has to store that 128 megabyte key or something like that. So if you have like 100 users, it's a lot of data, right? So if you're running a public server that is doing these type of services, you probably need like it's probably beyond the reach of a normal user to host that type of node. They can a normal user can say, yeah, let me run my own node with this oblivious message thing, but just for my own key. Yeah, that works, and it syncs and everything. So again, like I think theoretically it all works. It's just a matter of how the ecosystem is going to develop. It is quite complex. Many things can go wrong, but it is very promising. But it does make it more of a complex kind of architecture infrastructure rather than the simple Bitcoin, Monero, or even Firo style model where, yep, there's nodes, right? And you run the node and you're part of the network. Here now there's like several layers.
You got like a master node, maybe.
Yeah, master node with different functions, right? So yeah.
Yeah, so it seems like from like a network, from a scalability an infrastructure scalability standpoint, it seems like it adds it adds complexity, but improvements for scalability. Like as far as
that's right,
you could scale to a bunch of different users. Now, what about on the raw blockchain level size? As far as like our blockchain transactions, and are they still in that same size range as Orchard was, or are they smaller?
Yeah, it's exactly the same, but the difference is that as a node, you can aggressively prune. That means you don't have to keep although the transaction size may be big, you only need to retain a certain portion of it to retain the state, right? So yes, obviously the person that is doing the archiver nodes for academic and just like fallback sort of systems have to maintain this huge thing, but that's going to be a very specialized niche role. I suspect that most people will be doing the aggressively prune state, which in theory should be a lot smaller. And I think the only problem would be if I'm running a public node that's serving hundreds or thousands of users, then I need a serious machine to kind of handle all of that, right? Yeah.
Yeah. So right now, it seems like Tachyon kind of has all these changes to the infrastructure. Now, we talk about the biggest thing is it allows people to nodes, these special nodes, to aggressively prune. So how aggressively can, let's just say, a Monero node prune today, or a Firo node, or say Monero under full chain membership proofs or something? They're still able to prune nodes, right? Just maybe not as aggressively as far as like pruning transaction history.
There is some pruning, but I wouldn't call it even like significant. Like, because like even with Firo, you still have to retain the anonymity set. So if I look at all the transactions in Firo right now, I still have to download that anonymity set, which is a couple of 100 MB, which is like not that big in terms of what it is today, especially it's a one-time thing. But I don't know the exact amount that Tachyon would be, because I think I don't know if there's any sort of public figures, but it's gonna be a lot smaller. I mean, I wouldn't dare to put out any figures, but in theory it should be much smaller than what Monero or Firo is, but that depends again how many users and stuff like that, right?
Yeah, that was always like, there's so much nuance into this as far as like, scalability. And in fact, like before just now, I kind of assumed that Tachyon made the actual transaction sizes smaller and didn't just do this network level, scalability improvements, so that you basically don't have these nodes like have to be overrun with giant requirements as much in certain ways. So now let's get to like, I guess, the transaction speed nuances. And this, again, another layer of like complexity to the whole privacy thing. But so, for example, let's just start with like the Monero side of things. So today, from my understanding with Monero, you have to wait a certain number of confirmations before you send a transaction. And the way that mostly impacts people, it's not that you just receive some and have to wait before sending, even though that's true. It just, most people already have funds. It's that when you send, you get change back, and then the change to send a second time, you have to wait. And for example, I witnessed this. I knew it theoretically, but this year at PorkFest, I was hanging out with Paul from Edge Wallet, and he bought something with Monero, and then he went to another merchant like a couple minutes later, and he couldn't send again, and he had to switch to Litecoin and use that instead of Monero to buy something. So first of all, would you mind explaining why that is? And then is that going to still be a problem with full chain membership proofs, or is that just not a problem?
I'm not sure if I'm totally qualified today, but there's actually two elements to that. One is the dealing of the construction of the transaction, whereby do I need the previous stuff to confirm first before I can create a new transaction? That's one thing. And the other thing about the number of confirmations, that's more of a consensus layer, which is the nature of proof of work, right? It's just a pure proof of work. So I can speak definitely to the pure proof of work portion of why this is important, but not so much on the, I mean, at least I talk on the Firo side why we can't do it. I'm not exactly sure why Monero can do it. I'll check on that and I'll let you know. Maybe you can put like a little note in the video later.
But let me further,
let me talk about the consensus layer, right? Because proof of work, it's the same like Bitcoin, right? Yeah, technically one confirmation is secure for most people, but there is always a chance that block can be orphaned. And what an orphan block means is that, yes, there's another chain that has a more proof of work accumulated that then overrides the chain, the block that you already found, and that's confirmed, but somehow that chain has more accumulated work and overtakes yours. That's the way proof of work works.
It's
right?
like it's almost like an accidental 51% attack.
Yes, it's accidental. Like actually, right now, this is happening on Monero right now. Like even like Qubic, they are now starting to generate with the Monero and Qubic stuff. I don't know if we have time to explain all of that, but there are often blocks being generated on Monero network now. That means one confirmation probably is not secure, especially with an ongoing attack. you may want to wait. Like, I don't know, it's a kind of an arbitrary number, like 5, 6, 10 confirmations or something like that,
Yeah.
right?
Well, just to back on before we get into like the attack stuff, that's kind of interesting. But so the way you have to, like, if Paul from Edge is buying his stuff at PorcFest with Monero, let's just say next year there will be full chain membership proofs. Let's just assume.
Yeah.
And will he still have to wait that long between payments, or is it still the same issue, or because of the change in membership size, then maybe you'll just have to wait one confirmation and then that's fine.
This is a take it with a huge grain of salt. I doubt you will change that because obviously we just talked about the consensus layer. This one's like whether you need the previous anonymity set to be confirmed before you can generate a new transaction. I'm not so sure on that and how full chain membership proofs, but my guess is that it probably doesn't change that. That's just my guess, all right? So just take that as a guess, but yeah.
And so Firo has an interesting wrinkle to all this, which is instant send, which
That's right.
basically instant confirmations of transactions thanks to the masternode, something that is kind of Dash is famous for. And interesting from what I'm able to tell, and I'm like 90% sure, but again, grain of salt, because I've done some cursory Googling on this. From my understanding, PivX, which is forked from Dash, which has, I believe, Halo. Zcash.
No, it's still using
Sapling. Okay, yeah, there we go. I think because Halo was under the Bozal license for a bit, and so they didn't want to deal with that, and so
it's also a lot of engineering work.
Yeah, there's also that, but I guess the point is they had a version of Zcash's privacy, and from my understanding, they could not figure out how to make instant transactions work on that. And so more recently, they just removed it completely from the protocol. So now no PivX transactions are instant send. They're all just regular. Because I guess it just became too, what I would guess, again, this is, I got to give those disclaimers, right? But I would guess it's just because why would you have a feature that makes it more efficient in transacting in a way you don't want people to transact in? Because you want them to use privacy and therefore, maybe get rid of it. Make it less complicated. Anyway, that's just an assumption. I guess we'd have to talk to someone from PivX to say that. But so basically, they did not manage to get instant transactions with Zcash's tech. And from my understanding, Firo does have instant or relatively instant transactions for the Lelantus Spark transactions. So real quick, because you mentioned like what are the sort of parameters behind that, or what are the limitations behind that?
There's no, I mean, the limitations that, yeah, sure. So we have our private instant transactions, right? Actually, I was just thinking about it. It's not meant to throw shade at PivX, but PivX stands for private instant something.
So it's
right?
PivX.
Yeah.
You just have to say it faster. PivX. All consonants.
I mean, I'm a bit surprised. I'll probably have to talk to the PivX guys as to what were the challenges why they couldn't implement it. But we managed to do it in Firo, and in the sense that once the transaction has been kind of instant locked, you're not going to get any sort of conflicting transactions, and we can check this because there's I think what we call like the nullifier or tag, so that when we see something that's trying to span a conflicting transaction, because all private transactions still has to have a unique identifier to show that the double spend has not happened, right?
Yeah, of course.
And in this case, there's some kind of nullifier. Sometimes people call it the serial. I don't know what was the exact terminology, but because we can see, like, right, we are posting this transaction, as long as no one else has that same nullifier, we know that there is no double spend attempt. So we can actually treat the transaction like a normal transaction and say, yep, let's lock it in. The masternodes have agreed. Now we're not going to accept any conflicting transactions with that same nullifier or whatnot. So yes, we get those instant transactions in the sense that we know that once we get that instant lock, we are not going to see any conflicting transaction to the one that has been locked. That works similar with transparent transactions in Dash and Firo, right? Now, the only qualifier then is that we are not able to then spend like in Dash, or where it's kind of like chain span, right? Where A sends to B, and before B gets the confirmation, but it's already instant lock, B can start sending to C, and then C can send to D, and all these type of things, right? You can't do that with private transactions. It's because you need to know the exact order and you need to know the exact order and the state of the anonymity set before you can construct your zero knowledge proof. If that makes sense, because I need to make a proof that is based off all the stuff that has been confirmed. But if it's in the mempool and it could be like this one comes first, this one comes first, I will only know what the confirmed state is once a miner has confirmed, like, yes, this is the confirmed state. Then I can construct my ZKP proof. So I can get instant transactions, but I still need to wait for one confirmation before I can send that out. So that's kind of the limitation. It's it's a limitation, but we still get instant-ish transactions, right?
Yeah, it still works pretty well, I would say. And just for some historical context, for Dash from 2014, I believe, to 2019 or something, like a big chunk of Dash's history, instant send transactions were optional. You have to check a box that did it, and it would lock the inputs without chaining. And so I actually had this happen in conferences before, where I was sending out a bunch of transactions to people. Like I was literally setting up 100 people with wallets, sending them each a transaction as they went through the queue. And then I decided to demonstrate instant send. So I checked the box and sent it. And then I just couldn't send for a few minutes because the change was locked too. Like they got it instantly, but then I had to wait for a while. I'm like, oh no. And good thing that's not a problem anymore, but a 2.5 minute block time before you could send a second time or something, that doesn't sound that bad. Now, just off the top of your head, do you know if any Firo wallets have something kind of like Monero, the Monero wallet had like a pocket change function where they would have two different, like the balance would be split into like two different sets. So you could send once and then you could send again. It's kind of like having like a backup pistol. You shoot once and then you shoot again. So you could do that to mitigate those problems. So do you know if there's any Firo wallets today that have that kind of thing where you could potentially send twice? And would that be a good idea, do you think? Or would that cause other problems, do you think?
I don't. I mean, this is more on the implementation side. But, I don't think there's any limitation. It just needs to be architected and figured out, right? Obviously, the more inputs you have, the more, I guess it's when you're making a transaction, it actually has, it's a little bit more, right? But then, obviously, generally, you want to kind of consolidate your inputs into one big one. But as you said, there is benefit. Maybe let's say 2 or 3, we shouldn't add. So yeah, I think it's definitely an architecture problem. But right now, the wallets don't do that. We optimize for efficiency, but maybe we should optimize a bit for usability there, right? Yeah.
Yeah, I guess it depends on usage you see. Like if you see someone being like, I want to send and then send 2.5 minutes later. I mean, let's be honest also, like how often in the fiat world do people tap their card and pay something and in under 3 minutes they have to tap a second time? It doesn't.
That's right.
They can, but it just doesn't usually happen. So it's just something worth thinking about. And so the chaining doesn't happen, but and obviously the chain that I think the Dash transactions are like 24 hops before they have to be confirmed. But imagine how ridiculous that is. About like you have to do 10 every single minute, where you just 1, 2, 3, you're just like sending that thing everywhere. That's a little bit crazy.
Yeah, you actually have to have an actual try to hit that limit really hard, right? Well, what's the block time for Dash? It's also
like 2.5 minutes.
Yeah, so wow, you need to make 24 transactions chaining. I think by the time you finish setting up, it's like a block found.
Yes, yeah. And so as we mentioned before, at some point, Dash is looking into implementing confidential transactions, just raw CT, not with any of the membership proof type things. But so, do you think there's any limitations behind instant send or chaining instant send for just CT transactions, where you can't see the amounts, but you can see kind of where funds got sent?
I don't think. I mean, again, that's for the Dash side. That's why I was about to ask you: is there any limitation? But I don't think that it should hurt there because there's no membership that you're proving. You're just hiding the amounts, right? But yeah, I mean, I'll wait for the engineers and implementers to tell us that that's not possible. But it doesn't run into the problems that Firo faces when we're trying to do stuff. Because we need to construct the membership proof, right?
Yeah. So with Zcash transactions, right? So first of all, from what I know, Zcash has like 1.25 minute block times now. I think they reduced them at some point. And are, like, we talked about the limitations of like Monero, like how often you have to wait and things like that. Do you know anything about the wait times for Zcash, as far as like, is it just the same thing about like one confirmation?
Same thing. Well, I mean, it's proof of work, right? They haven't moved to any sort of hybrid model. It's still pure proof of work. It's ASIC mine. It's the exact same model, except that you just have a different mining class, right? You have ASICs instead of a CPU miner. So yeah, I would still say even one confirmation, you probably want to wait for a few. To kind of be honest, that you can wait 2, 3, 4 or so. It's not anything like what we have in Dash or Firo, where there's that kind of like guarantee, right?
Yeah, it's so. But from like a privacy perspective, there's no real issue in just sending. You get confirmed, sending again. Like none of that stuff it really matters because it's all about.
No, not with Zcash. Yeah, that's right. I think the only time where it would make a difference is that if you're moving between the transparent addresses and the shielding. So let's say like from the transparent, you get it from an exchange from a transparent address, then you shield it. And then you unshield it into somewhere else. Obviously, the time correlation there matters because everyone can see the entry into the pool and the exit of the pool, right? Especially if the amounts are similar. So there's that. But if you are just doing a Z to Z transaction, just operating totally within the shielded layer, there shouldn't be any kind of privacy issue there.
Yeah, that makes sense. Yeah, so it kind of is an interesting segue into like the proof of work stuff. So before we get too much into that, proof of stake doesn't necessarily have this limitation, right? I mean, there's obviously a whole different set of considerations and trade-offs there. But as far as like you don't really need to wait many more. It's hard. You don't necessarily need to wait as many more confirmations because orphans aren't as much of a thing in proof of stake usually. Like, do you think that changes things a little bit?
I mean, they are still offered blocks. They're not as prevalent as proof of work, but I don't think anyone is accepting single confirmation even on Ethereum, right? So I would say it's slightly different, but there's no like lock, right? So it's still not a single confirmation. There's a reason why all exchanges are like, oh yeah, 10, 20, 30 confirmations for Ethereum. And sure, the confirmations happen really quick, but it's still, I guess like Ethereum and Solana gets all around it basically because the confirmations are like find a block every few seconds or something really short like that, especially with Solana, right?
Yeah, I think I heard that Solana has like 400 millisecond block times. So like in like a second, you get 2.5 confirmations anyway, right? So yeah,
I guess like in proof of work, because the orphan blocks are like a natural byproduct of this like competitive mining thing, right? Because if two miners try and solve the puzzle at the same time and they broadcast it, then there's going to be orphan blocks. While generally in proof of stake, there is a validator that is chosen, like, this time is your turn to decide, right? So obviously orphans happen a lot less, but then if there's some sort of latency or some like the one that is proposing the block, there's some network issue, and validators miss it, then yes, that often can happen, but it is definitely not as prevalent as, let's say, in a proof of work model where often blocks are a part of it, right? Yeah, that's right.
Yeah, it's pretty interesting. So now the Qubic thing, real quick. So this has been an interesting store of drama kind of thing, I should say. So Come From Beyond, or whatever his actual name is one of the co-founders of IOTA from back in the IOTA is one of those big 2017 era projects, which oddly enough is still kicking. Come From Beyond is not involved with it anymore, as far as I understand, and there's some drama with drama. Crypto is drama, you know how it works. But so he has this project called Qubic, which is some sort of AI crypto based thing that uses mining, and basically there seems to be a point of drama because Qubic is mining Monero, and in a kind of hostile way, in order to use their own chain, kind of like almost like a vampiric type thing. And so just the context before we go into that is every cryptocurrency basically that has a specific algorithm, you can, from my understanding, build custom hardware or ASICs that target that algorithm over time. And so a lot of time people used to say that, Monero doesn't have ASICs, but then there was a lot of rumors that no, they really did have some ASICs at one point. And then eventually they changed the algorithm to, what was it? Random X. And then there was like 4 different Monero forks that split off at the same time. That kind of all went to zero, as far as I understand. I haven't checked up on them lately. And then now there's not considered to be any ASICs on Monero. So anyone could kind of mine with general hardware, like GPUs or something. And so that's kind of sets the stage for Qubic. CPU, sorry. CPU. Anyone can CPU mine Monero. So, this sets the stage for Qubic. So what do you know about the Qubic situation?
So first of all, Qubic, although it has mining, the mining doesn't contribute towards its consensus. It's actually, it's a quorum-based type of system, right? Whereby you have 600 validators or so, and then and what happens is that the mining process is, of this 600, I think only a proportion of them can earn rewards, and how they determine that ranking of whether you're in that subset of people that earn rewards is through the mining process, right? So actually it's like, whether the mining, the hash rate doesn't determine its security. It's just it's a competitive ranking model to say which validators earn money or not, right? So whatever attack that Qubic does and whatnot, the hash rate is not contributing towards Qubic's security, which also allows it to do this attack, right? And originally, what this mining was supposed to do is they call it useful proof of work, which is a bit of a misnomer. But basically, the original idea of it was that this mining was to compute things, the GPU loads or like machine learning type of things, and therefore that these nodes it's not actually part of consensus, it's ranking it, but I'm forcing the validators to do some sort of proof of work that may be used for training AI models and stuff like that. But as a marketing and kind of proof of concept, they decided to say, well, instead of doing AI loads, let's just use these spare cycles to mine Monero, right? And because of this, and obviously, Qubic's a relatively new thing. It's hot, it's AI and all of that. They use the mining, so they directed their useful proof of work to mine Monero. And when they mine Monero, they will take that Monero and then they'll buy Qubic, and then push the price of Qubic up, and this kind of creates what we call like a flywheel, which isn't an infinite money glitch as Come From Beyond says. It's actually like a bit Ponzi-like. But because of this, and it kind of also shows that the miners of today are just very mercenary. They will just mine what's going to give me the best returns on my GPU power, rather than let me mine a coin that I support and whatnot, which is also why we kind of move away from a pure proof of work system. And capitalizing on the mercenary nature of this, and because Qubic's price kept on rising also with this kind of buyback and all of that and all this narrative, it could, I think at the maximum, I think the Qubic pool that was mining Monero was acquired like 45% of the mining hash rate, which was of course very close to the 51% that you need to kind of attack Monero. And obviously Qubic's like, yes, he was using it obviously as a marketing stunt. But it does actually demonstrate the weakness of, is the security subsidy of Monero enough to keep its security, especially when you have another chain that doesn't rely on its security and has incentives to kind of attack and centralize it. It shows like, hey, yeah, proof of work may not be as secure, even as many people used to think. I mean, we've known this a long time, which is we got 51% attack. So we very personally know the issue, which is why we use a hybrid system. But Monero people were like, yeah, I don't like master nodes. It creates this privilege thing. It doesn't, it makes people cannot access it. But I'm like, now you kind of have to face the reality, right? So I'm not exactly sure what Monero people are talking right now and how to mitigate this. Of course, people say use P2Poo. I mean, P2Poo has been around for so long, and it's always, I don't think it's ever like taken up more than 10% of the hash rate. It's just actually less profitable to mine on P2Poo, which is why, again, miners care more about profits than actually the projects that they support. But yeah, I guess that's in a nutshell, right? Where Qubic was launching directing its useful proof of work to mining Monero. They were basically Ponzi-like things to kind of push it up, and a lot of incentives, because I think it was like 3.5 to 4 times more profitable to mine Qubic rather than to mine Monero directly. So it was kind of a no-brainer for many of these miners. But I think that proportion has dropped, and I think there's some evidence that Qubic may be attempting to do a 33% attack, which is like what they call a selfish mining attack. But yeah, I mean, this is like ongoing, right? But that's kind of it in a nutshell.
Yeah. And then there's some like, some extra like drama around it. Like, as you mentioned, like the marketing antics. And then there's some people in the Monero community who just say, this is a problem. Some would say, it's not a problem. And some say, oh, that's a big, and then there's been multiple DDoS attacks against Qubic, which, is kind of par for the course. There's also, there's some rumors that like there is this botnet cartel that has been sort of like running on Monero for a while that aren't like, wouldn't be considered like righteous Monero miners, that they are getting exposed by this, and they're the ones who are attacking. It's not just Monero people in general. It's just this one. So there's a lot of like extra spicy drama if you want to get into it. I mean, it's all kind of funny, but it seems like the undercurrent on all this is that there is a real vulnerability with this kind of proof of work system, this disloyal proof of work, as I would call it, right? This proof of work system where you don't have to have loyalty to one hardware, to one chain or one collection of chains, where you actually don't care about the chain you're mining on, which, I mean, it's been a long time since I went back through like the Bitcoin white paper and the early Satoshi talking, all that kind of stuff. But it seems like, the whole thing was set up where honest miners have better incentives to protect the network than maybe a dishonest miner, and the whole economics of the system work. Whereas it seems almost like if you have a system without loyalty in that way, the way things are set up now, it almost seems like mining doesn't really secure the network, really. It kind of does, but kind of doesn't. It's just almost like you're paying people to distribute your token on exchanges, and that's kind of it, right?
Yeah, I mean, like actually, the idea of commodity hardware mining, that means you can mine it with a CPU and GPU, was meant to be like a fair access. And yes, for a certain time it did. Like, people in Venezuela were mining Firo or Zcoin, to support their families and stuff. And like those was like, yeah, that to me was like, yeah, that's what proof of work, especially for a privacy coin that might be banned, to have access. Like, I don't need a specialized ASIC, right, which are only produced by a couple of manufacturers. But I think what we realized the hard way is that when you are targeting commodity hardware, that commodity hardware can be repurposed to mine other things, right? They could be mining another coin, they can be mining, they can be doing GPU loads, right, and all this other stuff, so that there's no economic loyalty towards your coin. And unfortunately, that is now the majority of miners. They will mine or do whatever that's going to give them money. And okay, sure, it makes sense, right? But it means that we have to really re-examine the model to say, like, yeah, is proof of work mining really like the main thing? While when you're talking about ASICs, right? Like for example, a Bitcoin mining or even Dash mining for the moment, well, I know it's a small proportion of it, but it's totally dominated by ASICs, and the ASICs can only mine your coin. They can't be repurposed to do anything else unless someone else makes another shitcoin with the same algorithm. And we've seen how that goes. It generally doesn't take off, right? But the ASICs in a way are kind of like a stake in the system, right? Like,
Yes.
you buy, you're buying, you're locked in, right? You have to make this coin work, or else your machine is worthless. So if you attack the thing that makes your machine worthwhile, you're going to lose the cost of your machine. Unlike GPUs or CPUs, despite the democratization thing, as a security model, I mean, from a distribution and fairness and yes, it's great, it's egalitarian and whatnot, but from a security standpoint, it's not ideal. And they used to be this taught to think that, oh yeah, Monero is always largely used in botnets, those where people do ransomware, and like in the meantime they're just mining Monero in the background. And because they receive Monero, there's this like symbiotic relationship, right, whereby yeah, hey, I'm blackmailing or attacking people. I rather receive this money in the privacy way, so I also support Monero. Obviously, there's some evidence. I wouldn't say how many proportion of the percentage is this, but there was this narrative that this was a symbiotic relationship, right? But I think the Qubic attack, I mean, I don't really like what Qubic's attacking, but it does highlight to say, yeah, that narrative only has certain limits if well funded and directed. And those are kind of smart, right? To create this flywheel, this economic incentives, even if it's unsustainable, to be able to almost approach, like attack Monero. I think it should be a huge wake-up call for any sort of proof of work system, especially those that have commodity hardware. ASICs, I think, I guess it's like, evil, and at the same time it provides good security for proof of work. But yeah, it is what it is, right?
Well, to give an analogy that's not at all thought through, but it's almost like ASICs are like government. You trade some of your freedom for this centralizing fort that kind of keeps you safe, and then no, ASICs is like warlords where you could do whatever you want, but someone could come through and raid your village. It's a little wild, but it almost seems like the ASIC world, it's almost not. ASIC mining is almost not pure proof of work. It's almost proof of like a hybrid model, because your stake is your ASIC. You got to buy your stake and then do that. And it's like, maybe not, but it does seem like it is a little bit of a conundrum in this case, because, for example, if there's a bunch of X11 coins for Dash, not any that matter really. Litecoin is a little bit more, because like the scrypt or whatever, there's a few other cryptocurrencies that do that. There's also merge mine.
They merge mine with Doge. So
yes, yeah. And a few other coins as well now. And now like Bitcoin with the SHA-256, obviously there for a while there were the other Bitcoin forks which were more competitive than they are now, maybe, although your Bitcoin Cash is trending back upwards. At the same time, like no one has really attacked those, because it's like, well, why would I could always switch from Bitcoin to Bitcoin Cash or vice versa if there's the profitability, but they're all kind of all in this very narrow ecosystem. Whereas now, like you would have to buy or rent a whole bunch of ASICs to attack. Whereas with something that like Monero, you could just any computers. You just go for it. And Qubic seems to be profiting off of kind of sucking off the ecosystem a little bit, but they're not a direct competitor. Now imagine if you had something like, I mean, Xano's a hybrid model, and they're really nice people too, so I wouldn't say that, but like something that does a lot of the same things that Monero does, maybe they just rent a bunch of hash to just sporadic.
They can't. Yeah, I don't know if they can do that because mainly like Xano's model and Firo's model, the proof of work still contributes to the security. While in Qubic, that proof of work has no component of security for them.
Yeah, or more just like a cheaper disruption attack, right? Because to completely shut down the chain permanently it's hard, right? But as far as like if you want to start orphaning blocks or reversing transactions, like once a week for a few months, you could just do a target attack, take it over, and you don't. When you're done with this disruptive attack, you just point the hardware elsewhere, some other chain, and so it just seems like it's a lot easier to just mess with things. Now, obviously, the big clear answer thing is always like, well, do a hybrid model like Xano has, or like Firo has, or like Dash has, or like even Zcash is looking into doing that kind of stuff. And like that seems to be like the obvious model. And if you don't want to go that way, if you want to remain proof of work and you want to remain ASIC resistant, are there really any kinds of solutions you could think of?
Not off the top of my head. And I probably have to end the interview soon. I'm actually late for my lunch appointment, but not at the top of my head. I mean, you can always have a hybrid model. There's always that other thing, but if you want a pure proof of work, it's hard.
You'd almost have to get ASICs back.
Yeah, and then no, I'm not trying to. I mean, this is my own personal opinion. I'm not trying to throw shade, but I'm just like, the whole point of proof of work is that, let's not talk about that nothing at stake thing, which, seems to be more of a theoretical issue. But the proof of work is more of like, that democratization, a bit harder to, stop people from spinning up and mining the thing and keeping it going. But if you can kind of do the same with proof of stake, why would you want to do a roundabout? And proof of stake, again, like from a user's perspective, it's better. There's less orphan blocks. You can have faster block times. All these, like, it's better for the environment, right? Why would you want to, if proof of work is not helping you with your democratization and distribution, and it's just like an ASIC thing, why would you want to stick to mining? I mean, that's just my personal opinion. I know the proof of work maxis would be really angry. I used to justify proof of work because of that democratization model, but now because of all these things and what we experience, we feel like that is kind of gone, right? Even Voscoin, who is like one of the top mining channels, he was saying, if I don't make a channel, use this, mine this, and earn $10, $20 a day, right? His views drop because miners are incentivized by how much money they make. Not like, hey, mine this cool new coin. Was more like, mine this cool new coin and earn up to $50 a day or something like that.
Yeah,
right?
Of course.
So yeah, that's kind of my hot or not so hot take on that.
Well, makes sense. Well, let's just wrap this thing up so you get some lunch out of it still. What would you shill before you go? Where can people follow you and etc.?
Well, I mean, just drop by our website at Firo.org. I'm on Twitter at Reuben, REUBENYAP. We're pretty active on Telegram and I guess it's bridged over to Discord. Give it a try. We'll have assets soon, which means that you can create your own tokens. We share in the same anonymity set as Firo, but yeah, I'm really bad at shilling. So just follow us and come by. We're really welcoming, and I think we try to be as honest as possible in the sense that we're not going to shit on other things if they're good, right?
Of course.
We're going to be objective and Dash, Pivax, and all of this. We all actually kind of now have a good friendly relationship. Even Decred, for that matter, all have a friendly relationship with each other. And we may have different approaches to things, but we all support the same goal. Yeah.
Yeah, absolutely. Well, cool. We're very good at having you on again, as always, and hope you have a good one and enjoy the lunch.
Right. Thank you so much.